In this presentation, we'll go over the second set of practice problems for wedge out. Here on the first one, let's look at what our conclusion is. Our conclusion is just the letter S. And I told you before when we're doing wedge out that we're going to find instances in which we're like, oh, it's just a single letter. It's just the letter S. It's right here. Can't I get it out? And the answer is going to be no, because I can't free up the S from this conditional statement with what I've got. So I look for something else. I look for a wedge, which I have right here. And so that's a pretty good inclination that I'm going to be doing wedge out. So I have my wedge. What do I need to do wedge out? Well, I need both of my disjuncts, and I need to show that they both lead to the conclusion. So I need both of them to show that they'll arrive at S. So we need to identify our disjunction, which we do in line 3, and then we need to prove each of these different conditional statements. So we've already got this one. We need to prove P arrow S, so we need to assume P as a PA and look to prove S, and, well, we can wedge in our T on P, and then we can get S from 1 and 5, arrow out, 1 and 4. Then we can arrow in, because we got the consequent we are looking for. It depends upon our PA and 4. Arrow in. The 4 will drop out, so that's the second one we are needing. Now we just need to create our third statement. So we'll assume Q is a PA, and we'll look to prove S. Same as before, we just wedge in the R, because that's what we're going to need for our conditional statement in 2. So we're going to do 8, wedge in, 8, and then we can get S and L from 2 and 9, arrow out. 2 and 9 is 2 and 8. We're looking for just S, so we'll remove the S from 10, doing ampersand out. And then we can build our conditional statement from 8 and 11, arrow in. We're going to get rid of the 8 because that's our PA. Now we've got our other statement. We've got our Q arrow S, so we can just write S. And let's just identify these in the problem. Let's see. I've got P arrow S here. And I've got, make sure I get the green, Q arrow S here. And so that's going to be from 3 is my disjunction. 7 is one of my conditionals. 12 is my other conditional. I'm doing wedge out. And those are going to be 1, 2, and 3. Don't need these other numbers. So that is problem 1. Here on problem 2, our main operator is the conditional statement. So we know immediately that we are going to be assuming the left-hand side as a PA, and we're going to look to get to T by itself. Well, let's look at what we've got now. And we don't have the antecedents for the conditional statements in 1 and 2. We do have a wedge in 4, so maybe we can do our wedge out, which is P or S. And then so we're going to look for P and S to both lead to our conclusion. And so we've already got the first one, as always. So we need to build P, arrow T. So we'll assume P. That will be another PA. We'll look to prove T. Well, we can prove T by putting P and Q together from 3 and 5. And in 3 and 5. Then we can get T from 1 and 6, arrow out, 1 and 6, 1, 3, and 5. Then we can build our conditional statement that we need because our PA gets to our consequent. PA's in 5, 7 is our consequent. We're introducing an arrow, and we are getting rid of the 5, the PA that's associated with 5. So that is one of our conditional statements. We should improve the other one now, so we'll assume S as a PA, and we'll look to prove T. So same as before, we just need to put the S and the Q together. 3 and 9, ampersand in, 3 and 9. Then we need to get the T out from 2 and 10, arrow out, 2, 3, and 9. Now we've got to our T, depends upon our PA, our S, so we can S arrow T from 9, 11, arrow in, 9, 11, so be 2, 3, and 9, but the 9 will drop out because that's our PA, and so that's our second conditional statement that we're needing. So with that, we can prove T doing wedge out 4, 8, 12, wedge out 4, 8, and 12 have 1, 2, and 3. And now we got to our consequent. It depends upon our PA, P or S. So we can arrow in doing 4 and 13, arrow in. 4 and 13 have 1, 2, and then the 3 will drop out. We don't need the rest of these. So we had to do the wedge out, and then we did the arrow in off of that. Here in problem 3, our main operator is the arrow. So we know that in line 4, we need to assume P and look to derive R. So we'll assume P is a PA, and we'll look to derive R. Well, what we can do is we can toss the P into 1 to get Q arrow R, but we're going to end up getting stuck. So we recognize that we've got a wedge in T or Q. So what we should be doing is looking to find a wedge out in which both of these lead to R. So we've got our disjunction here. We need to get our two conditional statements, so we'll start by assuming T as a PA, and we'll look to get to R. So with T, we can get P arrow R from 2 and 5, arrow out, 2 and 5. Then we can toss the P into this one, and we can get R. So from 4 and 6, arrow out. That's going to be 2, 4, and 5. Now we can build our conditional statement from 5 and 7, arrow in. 5 and 7, 2, 4, and 5. The 5 drops out, and that is one of our conditional statements. Now we look to get the other conditional statement, so we'll assume Q as a PA. Here in 9, we can toss the P into 1 to get Q arrow R from 1 and 4, arrow out, 4. Then we can toss the Q into that conditional statement, so from 9 and 10, arrow out, we can get R. That's 1, 4, and 9. Now we can build the other conditional statement that we need from 9 and 11. Arrow in. The 9 will drop out there. Now we've got our other conditional statement. We can write R here in 13 from 3, 8, 12, wedge out. And that's going to be 1, 2, 3, and 4. And then the last thing we need to do is just arrow in with our P that we assumed in line 4. So that's going to be from 4 and 13, arrow in. It'll be 1, 2, and 3 because the 4 drops out. The rest of these numbers are not needed. So that's problem 3. Here on 4, we have a disjunction here. And we have we have a ampersand as our main operator, but we got two conjuncts that we need to find and put together. But what will probably be easier is just working from the wedge out scenario and then start building that way. Because typically when we think about a conjunction, we say, well, I need T and I need R. And once I find both of those, I'll do ampersand in. We'll be doing that, but it's probably better just to think, I need to do wedge out, and I need to get to T and R. So, S, T and R, and P arrow, T and R. That's what we're looking for. We already have our disjunction, so we just need our two separate conditional statements. So we'll do the same thing as we have been. We'll assume the antecedent of the first conditional statement that we need, and look to prove T and R. Well, we can take this, wedge in an S, and then we can use this to get R and T out from 1 and 4, arrow out, 1 and 4, it's going to be 1 and 3. Now, we do need to break these up from 5 ampersand out. And then put them back together the way that we need them. 6 and 7 ampersand in. Then we can build our conditional statement from S, arrow, T and R. And that will be from 3 and 8, arrow in. 3 and 8 has 3 and 1 and 3, but the 3 will drop out here. So that's one of our conditional statements. Now let's look for the other conditional statement. So we'll assume P as a PA, and we'll look to prove T and R. So same as before, we'll just wedge in S. Then we will get R and T out from 11 and try to keep consistent. Arrow out. 10. Now we got to break those two apart. 10, 10. Put them back together the way we need them. Then we can build our conditional. So we assume P got to T and R. So that's going to be from 10 and 15. Arrow in. 10 will drop out. So it's just going to be 1. there is our other conditional statement that we were looking for. So we can write T and R from 2, that's our disjunction. 9 is one of our conditionals. 16 is another conditional. We are doing wedge out, and that's going to be from 1 and 2. So I'm going to draw a line here to make it easier. There we go. And so that's problem 4. So here, the main operator in our conclusion is an arrow. So we know that in line 4, we're going to assume the antecedent and look to prove a contradiction. And based on what we've got, we can't really do anything else. So we should look for a wedge out scenario in which we can get to our consequent from both of our disjuncts, like so. We've got the disjunction already. Now we are looking for these two conditional statements, so we'll assume P is a PA, and we'll look to get to S and not R. Well, we can get tilde R and T from 3 and 5, arrow out, 3 and 5. Then we can get our tilde R out from 6, ampersand out. Now we're still looking for our S, and the only way we're going to get our S is by eliminating the conditional with Q. Well, we can branch over into Q by doing our double arrow out on 1. And then we can toss our P into this to get Q. So that's going to be from 5 and 8, arrow out, 5 and 8, and 5. Then we can toss our Q to get T and S from 2 and 9, arrow out. It's going to be 2, 1, 2, and 9. Or, sorry, 1, 2, and 5. Then we can get our S separated from that from 10 ampersand out. So 1, 2, and 5. Then we can put them both together, our S and not R, from 7 and 11 ampersand in. So that's going to be 1, 2, 3, and 5. Then here in 13, we can finally build our conditional statement, P arrow, S and not R, from 5 and 12, arrow in. And then we're going to drop out the 5. Now we just need to redo everything we just did to get our other conditional statement. So this one is going to be quite long. We're going to assume Q is a PA. Then we're going to toss this into our conditional statement into then we can get our S free from that 15 ampersand out to 14. Now we need to do the same thing just in the opposite direction this time with our 1 double arrow out. So we can get our P from 14 and 17 arrow out. Then we can toss that into the conditional statement in 3 to get tilde R and T from 3 and 18 arrow out. So that's going to be 1, 3, 14. Then we can get our tilde r from 19 ampersand out. I'm going to erase our little notation thing here because we're just not going to have enough room as it is. So we need to put S and R, or an S and tilde R together from 16 and 20 ampersand in. That's going to be 1, 2, 3, and 14. I need extra in there. Don't want to confuse that with a 4. There we go. Now we can build our conditional statement here, doing Q arrow S and tilde R. So that's going to be from 14 and 21, arrow in. 14 will drop out. Then, finally, we can arrow in on our PA. Actually, sorry. Before we can do that, we have to erase this because I'm going to need one extra line. We can write S and not R because of our wedge out. I knew we needed to use wedge out. Just totally blanked on that step there. This has gotten pretty long. 4, 13, and 22 wedge out. So that's going to be 1, 2, and 3. And then, finally, we can arrow in, doing our P or Q, arrow S and not R. And that's going to come from our PA in 4 and our consequent in 23. 3 will drop out. So that's a super long one, but remember it's just doing this in steps, in stages. So you have this all the way up to here, then you have this all the way down to here. Although there's a bunch of steps there, they should be nearly identical, just with different numbers. You see PA, arrow out, and out, double arrow out, arrow out, arrow out, and then sorry, that's a terrible ampersand there. Not like that one's much better, but that's an ampersand there. Then we're doing ampersand out. Let's just try to prove that one more time. Still not great. There we go. Ampersand out, ampersand in, then arrow in. Then on the other one where we start with Q as a PA, you see PA, arrow out, double arrow out, double arrow out, arrow out, arrow out, ampersand out, ampersand in, arrow in. It's the same rules, just getting used on a couple of different premises at different points, but they look generally the same. And again, this is a really long proof, which is why we're not doing so many in these practice problems, because they do take a while. But it's just following step by step what we're trying to do based on the main operator, and then based on the fact that we need to use wedge out. Again, we see here in problem 6 that our main operator in our conclusion is an arrow, so we should be making a PA of the antecedent, which is probably going to be an indication that we're going to have a wedge out. So we're going to be looking for these. Again, how I'm basing this is I have only one wedge to choose from, and the wedge is always directed towards the sought after conclusion or consequent. So that's going to be my only direction to take this, and I've already got my wedge here, so I need to build my two conditional statements. So I'll assume P is a PA. Oops. Mark that as 4. Now what can I do? Well, I can separate out the P double arrow Q and the S from 2 ampersand out. Then I can break apart my double arrow, which I'm going to do both of these at the same time. So I 5 double arrow out, 5 double arrow out, 2 and 2. Now I can toss my P into this to get Q. So that's going to be from 4 and 7 arrow out. 4, I erase that real quick. 4, 7, have 2 and 7. Now I can put the P and Q together from 4 and 9 ampersand in 2, 4. Sorry, meant to put a 4 here before. 2 and 4. And then I can get the S arrow T from 1 and 10 arrow out. 1 and 10 will be 1, 2, and 4. Then I can get T from 6 and 11 arrow out. That should be 2 and 4. And now I got to my consequent that I was looking to get to, so I can arrow in. P is at 4. My consequent is at 12, doing arrow in. So the 4 will drop out. We just have 1 and 2. And that is our first conditional. Now we just need to prove our second conditional. Doing the same thing again. So we can get P from our arrow out in, let's see, 8. So it's going to be 8 and 14. Arrow out. 8 has 2 next to it, 14. Then we can put them together. I don't need the parentheses just yet. So that's going to be from 14 and 15 and in. 2 and 14. Then we can get S arrow T from 1 and 16 arrow out. 1, 2, and 14. Then we can use our S to get T from 6 and 17 arrow out. 2 and 14. And now we've got our condition, or we've got our PA. We've got our consequent that depends upon the PA, so we can build our arrow from 14 and 18. And we'll drop out the 14 there. I'm going to need to erase this again. Give myself a little bit of room. So now we've got our other conditional statement here. And we can write T from 3, 13, 19, wedge out. So that's going to be 1, 2, and 3. Now we got to their consequent, depends upon our PA, so we can just arrow in, like so, from 3 and 20, arrow in, and then 3 will drop out. So here again, we see a conditional statement as our conclusion. So we're going to assume everything on the left-hand side of it as our PA. And we're going to look to prove the consequent. So let's start by breaking this PA down by doing AND elimination. On 3, and we might already see that we have a wedge here as our main operator, so we're probably going to be doing wedge out. So that means we should be looking for this. So what can we do? Well, actually I guess first we should assume one of the disjuncts is a PA and look to get P. So I can take T. What can I use that on? Well, I can't use it on anything yet, but what I can do is I can wedge in my Q, or at a Q on my S from 4 wedge in. And that would give me the ability to get T arrow P out from 1 and 7 arrow out. 1 and 7 have 1 and 3. Then I can use my T to get P from 6 and 8 arrow out on 3 and 6. Now I can build my arrow from 6 and 9 arrow in, and that will drop the 6 out. So we needed this, we needed this, which we got this now. Now we need to get our other conditional statement, so we'll start with tilde L, and we will mark it as a PA, and this time we'll wedge in a tilde R on our S, so that will be from 4 wedge in, which has 3 next to it. Then we can get tilde L arrow P from 2 and 12 arrow out. 2 and 12 have 2 and 3. Now we can toss our tilde L into that and we can get P. So that's going to be from 11 and 13 arrow out. 2, 3, and 11. Now we can build our arrow from this, doing 11 and 14 arrow in. So we can drop our 11 out. And something I just realized now, and you may have realized it before I realized it, but we didn't have to do all this. Whoops. We could have stopped at that point here because this is equally our conditional statements that we were looking for. So in this instance, didn't actually have to do all that work, but you can see how when you get into a sort of mode that you continue to sort of follow the same steps that you have been doing. It doesn't really matter that we did the extra steps because we could still cite P here in 16 and that would be from 5, 10, 15, wedge out. We could have just as easily cited, let's see, T and P are at 8 and 13, so we could have cited those instead, since those are also the conditional statements that we were needing. So really, either way works. We did extra steps by assuming the tilde L and assuming the T, because we didn't have to do it. We could have just arrowed out on the two things that we were needing from 1 and 2 once we wedged in on the S. But again, not a big deal. Proof is still the same as it is. So we'll just keep it and we'll finish it off, because now that we've got P, I guess I need to make sure I got 5. Should be 1, 2, and 3. And so that depends upon our PA and 3. And I need that extra set. Actually, yes, I do. E, and it's going to be from 3 and 16, arrow in. And that means the 3 will drop out, and the rest of these are not needed. So that's problem 7. So this last problem is a real challenge. I thought it would be fun just to sort of give you a really difficult problem to finish off this course. If you didn't get it, it's perfectly fine, because this one is really difficult. It requires you to really think about the stuff that we've talked about in the previous weeks and the sort of game planning that you have to do to arrive to the correct conclusion. So it's fine if you didn't get this. You're not going to get tested with a question like this. But it might have been fun, might have been a good challenge for you. And so I want to go through it real quick. Here, the conclusion, the main operator is a tilde. So that right away tells us that we need to assume the opposite of the conclusion and look for a contradiction. So we need a contradiction. And you might say, well, I got a Q and a tilde Q here. Maybe that's a good start, and it probably will be, because that's the only contradiction that we'll be able to build throughout this proof. So let's work towards that. Well, we're still going to have to do wedge out somehow. So we're going to need to do wedge out. But what are we wedging out to? That's the question. Because usually we wedge out to the conclusion, which is tilde P or S. Well, in this instance, we're going to be looking for not that, but we're going to look for Q and not Q. We're going to look for our contradiction. I'm going to have to this one up here to S, arrow, Q, and not Q. So that right away would have been a pretty difficult thing for you to figure out, that we're working towards Q and not the actual conclusion. Because what we're going to do is we're going to tilde in on the conclusion at the very end. So we needed to look for this contradiction that our disjunction leads to the contradiction either way. So we'll still assume P as a PA, and then we can get a Q out from 1 and 5, arrow out, 5. Then we can do our biconditional out on 3, and we can toss our P into that to get S. So that's going to be from 5 and 7, arrow out, 3 and 5. And now we can get our tilde q from 2 and 8, arrow out, 2, 3, and 5. Then we can put that together from 6 and 9, ampersand n. So that is one of our, let's see, 6, 9, 1, 2, 3, 5. Now we need to just build the conditional from 5 and 10, arrow in. We'll drop out the 5, so it'll be 1, 2, and 3. And then we just need to do the same thing over again. I'm going to have to erase this box down here because I'm not going to have enough room. I'll be lucky if I can finish it with what I've got written right now. But we'll assume S, which is our other disjunct. And then we'll look to prove Q and not Q, which we can get not Q from 2 and 12, arrow out, 2 and 12. Then we can do our biconditional out to get the other version, 3, double arrow out, 3. Then we can toss our S into this to get P from 12 and 14, arrow out. So that's going to be from 3 and 12. Then we can get our Q from 1 and 15, arrow out. 1, 3, and 12. And now we can put our Q and not Q together from 13 and 16, ampersand in. 13 and 16 is going to be 1, 2, 2, 3, and 12. Better erase that to get a little bit easier to read. 12. Now we just need to build our conditional. So that's going to be from S to Q and not Q. So 12 and 17, arrow in. 2, 3, 12 drops out. So then I can write Q and not Q from, here is my wedge. Here is one of my conditionals, and here is my other conditional. So from 4, 11, 18, wedge out, and 1, 2, and 3. Now I've got a contradiction, depends upon my PA. Depends upon my PA, except for I forgot to include it in this line here. This should be 1, 2, 3, and 4. So it depends upon my PA, and then I can tilde out on my PA, and that's going to be from 4 and 19, tilde n. And it's going to be 1, 2, and 3, because this 4 drops out from 19. So, like I said, this one was pretty difficult, and it's pretty long as well. But and what made it difficult was the fact that you had to realize that you're building your conditionals towards the contradiction and not the actual conclusion. If you got it right, great job, and way to put it all together that we've talked about in the past weeks. If you didn't get it, that's totally fine too. Just make sure you're comfortable with these wedge out problems, so keep reviewing this lecture and the previous lecture until you feel pretty comfortable with it.